Hey guys, in today's lesson we're going to be looking at one of the cornerstones of functions in the IB, one of the most asked and quizzed upon topics called domain and range. We're going to look at how to determine the domain and range in this video and what exactly it is. This should make up some of your basic functions knowledge in order to actually undertake the IB AAHL maths exam, or I've seen this come up under a range of exam boards. So yeah, let's get into it. So first we need to actually identify what is the domain and range. So the domain is defined as a set of values which the variable can take. So this is basically just a restriction, or just looking at the values or range of values that the variable on the horizontal axis can take. This is usually x, so usually x. So it's just defining the value of x, or the range of x that can be taken. We say it belongs in a set of values that are in a domain, and the domain being the set of values that x can take. So the range is the same thing but for y. So a set of values which the variable on the horizontal axis can take. This is usually y. I'll give you guys a few seconds to write this down and kind of digest this before we move on. Feel free to also pause the video at any time. I know that if it is your first time, it will seem like a little bit much. So I can show you just a simple diagram to show what I actually mean by domain and range. So let's just say we have a random function. Just draw it like that. So what would we identify as the range of this function? Well, the range is literally just from the max y value to the lowest y value. This would be the range. So y can take a value inside of this set of values. And what would be the domain in this case? Well, the domain would be from the lowest x value here to the highest x value. This is the domain. This is what we would say is a set of values that x can take. So in this area, it will be x. Alright. So the domain and range of an equation can be described in several ways. Here, I'll give you a few examples and what they actually mean. So let's look at the first example. So there's different ways that we can show a domain or a range. There's set notation, bracket notation, or as a number line graph. Usually in the exam, when it asks you for the domain, you want to write it in either set or bracket notation. However, understanding the number line graph is also helpful. So let's say we're going to write a domain here. So we'd say that x, we'll write it in this format. X. So write out first, and then I'll tell you what all of these mean. Okay. So what does this mean? This means the set of all x such that x is greater than or equal to 3. So the set of all x such that x is greater than or equal to 3. Alright, so what this means is basically it's the value of all of x, it has to follow the rule that x is greater than or equal to 3. So for all of the x values on a function, the x has to be greater than or equal to 3. This is written in set notation, and this is written in bracket notation. So here in set notation, we can see that it reads as the following: x such that x is greater than or equal to 3. In bracket notation, we can see that x is an element, so meaning that x is a part of 3, comma, infinity. Well, what does this mean? Well, it means that 3 is the lower limit of x, lower limit. And as in this statement, x is only has to be greater than or equal to 3, which means that it has an infinite number, so the upper limit is infinity, as it can take any value that is greater than 3. Let's look at another. So let's see, for example, where x is actually less than something. So x such that x is less than 2. Now in bracketing notation, sorry, it's meant to be a bracket, so I'll just write like that. Alright. You might also see that the brackets in reverse, so the brackets would look like this. This is the correct way to do it, but I think the examiners will also be lenient if you do write like the correct way, but usually you want to write it like that. I just wrote like this in the first example, just so you could easily digest what was actually happening in a more relatable fashion. So as a line graph, we'll see 2. You can see that this dot is filled. This means that x can take the value of this. If it was a hollow dot on the example, x cannot take the value of 2. So we have a dot. So what does this mean? What does this exactly mean? So it means the set of all x such that x is less than 2. Alright, so what does this mean? Well, what this means is that for all of the values of x that x can take, x has to be less than 2, basically. So here, you'll see on the left we have negative infinity. This is our lower limit. And 2 is our upper limit. But we can see that x is less than 2. There's nothing saying that there's a certain number that x has to be greater than. Therefore, we just assume that it's negative infinity, as it's not stated in this function that x has a lower limit that's actually defined. So like we can't say that, like in the other one we can see that the x is greater than or equal to 3. So we just write it as negative infinity, as x can take any value less than 2. Alright, now moving on. For the range, by the way, you literally just replace all these x's with y's, and it's the exact same thing. So for this one, it'll be like the set of all y values such that y is less than 2, and you just replace it with y's. Now let's look at when we have another inequality. How would this be written in bracketing notation? Well, it would be written as x is an element of -2, right, in the number line now, you'll see what I meant with the hollow. And so -2, 1. look here, x is only less than, negative 2 is only less than x, and is not equal to x. Therefore, we use a hollow dot. X is less than or equal to 1, so x can take the value of 1. Therefore, we have a filled in dot, and we'll join them like so. What does this mean? Well, this means the set of all x such that x is between negative 2 and 1, including 1. So it means that the value of x is between, the value that x can take is between negative 2 and 1, including 1. So here, you can see here, we have our lower limit of minus 2, and our upper limit of 1, as that's the highest number it can achieve, and this is the lowest number. Alright. Now let's see if the inequality was separated. We would have x or x is greater than 4. How do we write this? What does this mean exactly? Well, it means that for all the values that x can take, x has to be less than or equal to 0, or is greater than 4. So it can't be both simultaneously. That's why we have them separated. Because x can't be greater than 4 and less than 0 at the same time. It's impossible. That's why the inequality is separate this time. So here we'd write x is an element of, of negative infinity of this parameter. Or infinity. Basically, as x is less than or equal to 0, again, there's no lower limit for x defined, therefore we just take it as negative infinity, and the upper limit being 0. And in the statement x is greater than 4, there's no upper limit, so we just take positive infinity, and the lower limit is 4. And that's it for that question. Now we're going to run through some quick examples to test your understanding. So let's look at this example here. Find the domain and range of the function following. So f of x equal to root x minus 5. Alright, so finding the domain of a function is, in a sense, just finding the set of values that x can take, where x, so therefore the function has to be defined. So what we have to do is find f of x, where f of x is defined. So it's a range, it's a set of values that x can take for the function to be defined. So, well, how could we find this? So we can say x minus 5 is defined where x minus 5 is greater than 0, or equal to, it can be greater than or equal to 0. Why? Well, we all know that the square root of a negative number leads to a number that is not real. Therefore, undefined. The function will be undefined in this state. As we only have variables x and y, we don't have a real or imaginary axis, so therefore the square root of a negative number will produce a complex number, meaning that, or an imaginary number rather, which will mean that it's not real. Therefore, we can state that x minus 5 is defined where the square root of x minus 5 is defined where x minus 5 is greater than 0. Well, we can say this. Well, x minus 5, so where would x minus 5 be equal to 0? Well, where x is equal to 5, right? That means that x cannot be less than 5, otherwise it will be less than 0, and then it will be undefined. So x has to be greater than 5 than 5. Sorry, I meant greater than 5, by the way. X has to be greater than 5, because otherwise x minus 5 will result in a negative number, which will then be square rooted, and as we know, this will lead to an imaginary number, which will be undefined, which will mean that the function is undefined. So x has to stay in this area. So how would we write this? We'd write this as x is greater than or equal to 5. Now we're going to be looking at the range. So as we can see, the square root of x minus 5. As we know that the function is undefined where root x minus 5 is equal to the square root of a negative number, right? Well, that would therefore mean that the square root cannot be negative. So the y has to be greater than 0, as y is equal to x minus 5. This is equal to y. And the square root of x minus 5 is undefined. So y is undefined where root x minus 5 is equal to 0, or less than 0. It's less than 0 and negative. Therefore, y has to be or cannot equal 0, otherwise undefined. So we can write this range as y such that y cannot equal 0. As where y equals 0, it will be undefined. Oh wait, no, it will be y is greater than or equal to 0, because where y is negative or less, then it's undefined. So therefore you would write it as y is greater than or equal to 0. Sorry, I was looking at the wrong question. And this, so yeah, the square root can't be negative, so y is greater than or equal to 0. Alright, so let's look at another one. F of x is equal to 1 over x minus 5. Well, we can see that 1 over x minus 5 is defined where x minus 5 is not equal to 0, as any number divided by 0 is undefined. Therefore x cannot equal to 5, as 5 minus 5 is equal to 0. So how would this be written? We can just write it as the domain as x cannot equal to 5. You come to notice that finding the domain is just looking at where the function is defined and where it is not defined. So we can now look at the range. So no matter how large or small x is, y equals f of x will never be 0. So let's look at that. So the function of x in this question is 1 over x minus 5. Y is equal to 1 over x minus 5. So for this to be 0, it's impossible. Well, why? Because what does this function actually look like? Well, it looks like this. It will have an asymptote at 5, and it'll be like this. And hence we can see that y cannot equal 0, because no matter how small or large x is, y will never be able to equal to 0, because 1 over 0 is equal to undefined. And no matter what x is, y can't be 0. So therefore the range is y such that y cannot be equal to 0. Let's look at another one. Let's say 1 over square root of x minus 5. Well, again, x minus 5 has to be greater than 0, but it cannot be equal to 0. Why? Because root 0 is equal to 0, and then 1 over 0 is equal to undefined. Therefore, it cannot be equal to 0. And also, it has to be greater than 0. Why? Because the square root of a negative number results in an imaginary or complex number being found. So, the domain is x has to be greater than 5. So we write x greater than 5. Now, y equals f of x. F of x is that. So y is equal to 1 over square root of x minus 5. Now, what does this mean? This means that y has to always be positive and can never be 0. But why is it always positive? Well, the square root of any number is positive. Why? Because when you're squaring a number, if you're squaring any number, you would always get a positive outcome. What? Even if it's negative, the negative cancel out and give you a positive. Therefore, the square root of any number is positive. Therefore, y can never be negative, no matter whatever x is, and it can never be 0 because to obtain that it is impossible. So y has to be greater than 0. Alrighty, let's look at some further examples. Alright, let's look at the natural domain now. So here's some examples of the natural domain. So if the domain is not specified, we can use the natural domain. So if domain is not specified, natural domain can be used. So it is basically the largest part of the real number system where f of x is defined. Here are some functions that you should know and you can be tested on. So we can have f of x, root x, 1 over x, 1 over root x, which will give you, so x is part of the real number system, x has to be greater than or equal to 0, x cannot be 0, and x has to be greater than 0. Why? These can be seen through inspection. X is an element of the real number system, x squared, x has to be real, and yeah, you achieve this. Root x, x has to be greater than or equal to 0, as discussed previously, as the square root of a number has to be positive, and also you can't square root a negative number without getting a complex number, therefore it has to be greater than or equal to 0. 1 over x, x cannot equal 0 because any number divided by 0 is undefined. X also has to be greater than 0 here, has to be greater than 0 here. Why? Because 1 over the square root of x, where if x is 0, then you just get root 0 and you get 1 over 0, which is also undefined. But also if x is less than 0, you get like root minus 1. What is this? This is 1 over I, and you have a complex solution, which is impossible when we're working in the xy plane. Thanks for watching. I hope you understand domains and ranges a bit better now. And yeah, if you have any feedback, please leave it in the comments below. Thank you.